this bolt. One of the oldest inventions and one of the 6 simple machines the screw is. It is a circular climbing inclined plane. It's a wedge, it's a lever, it's almost all the 6 simple machines in one. But these are threads. We all know these. We use these all day long. And I've been attempting to single point 18 threads per inch. And I've been failing. This is the chart by which you adjust the threads, the pitches of cutting on your lathe. This whole thing is full of gears. In fact, this arrangement is effectively a kind of a mechanical computer. Not on the money. Look at that. It's wrong. Clearly, that when I'm trying to cut 18 threads per inch, and I set my lathe to cut 18 threads per inch, it says, "Great idea, boss. I'm happily cutting 16 threads per inch." Then I went and I Googled this. And it turns out that on the practical and home machinist forums, it seems to be that almost every lathe that has a complex chart for threads has a couple that are not right. I don't know about you, but I'm shocked. I'm also not necessarily surprised. It's a mechanical computer. There's a lot of moving parts. I was planning to do something else today, but the best laid plans and all. I am confused. It seems that none of my settings are correct. 2, 3, 4, 5, 6, 7, 8. There are 8. And of them, 7 of them are of one kind and 1 is of another. You see where I'm going with this? So, what I'm going to do is I'm going to chuck a piece back into the lathe. I'm going to move this setting one at a time. I'm going to choose 20 threads per inch, something I can easily see. And then I'm going to put this on the correct setting, and then I'm going to move it and cycle it through all 7 settings. And if one of those gives me 20 degrees, let's just say that the setting for, the setting for 20 threads per inch would be 5. Okay, so I'd have this on 5. If everything is set up correctly with this, then 5 plus the other settings should give me 20 threads per inch. When it doesn't, because it won't, because it didn't, I would then simply try cutting 20 threads per inch on 4, 3, 2, 1, and then 7, 6. All the other possibilities. And if one of those possibilities gave me 20 threads per inch, the next thing I do is pull this wheel off, set it so that that's 5, and that, in theory, should then fix all the others. If 5 should be 1, then I'm going to just put a piece of tape on this that changes all these numbers. And then I'm going to try them out. So I think this might be the first time I've realized that this is off. The question I'm trying to answer in my head is, did this happen before I got this lathe, or has it been something that's happened since I've had it? When you pass it through something other than the center, there's only one position this goes on the shaft. So that was meant to make this a non-screw-upable part. You know what? Let's see if this fixes the problem. And if it does, then I'll go in. If it doesn't, then it's something else. Okay. I don't know how to finish this project, but I now know what the next step is. The way I described thinking through this problem is exactly my favorite kind of problem solving, waking up in the middle of the night and being like, oh, wait a minute. And it's just about, all I'm doing is thinking about the system in different ways. It's actually, each of those ways is like a different lens. So,
welcome to Practical AI, everybody. My name's Jeff Northrup. This is Peter Lynn. Today we're going to discuss problem solving and models. And really the question is, what is the equivalent of a gearbox in a machine learning model? Peter, Adam Savage's video was pretty fun to watch, seeing him kind of figure out, his problem and get to the root of fixing it. But it demonstrates a lot of complexity, right? That in a system or a device that does something complex, there's a lot of inputs and a lot of ways that, in his case, a lot of gears that are adjusting, the rates of different things and depths and how does a machine learning engineer, how do they think and problem solve that way, given the current way that AI engineers, all the tools that they have to work with today?
Yeah, great question. So before we start, I think when I watched that video with Adam, the thing I love about his videos and a couple other channels like Stuff Made Here is they walk you through the actual problem solving process of like, here's my problem. And then they'll try things and they'll make mistakes. And they document, explain their thought process of like, oh, actually, this assumption was completely dumb. In the case of Adam, his lathe wasn't cutting threads the way he wanted. He wanted 20 threads per inch, and it was doing something different. And so he went through the process of explaining, okay, there's all these knobs, these levers on a lathe, and a lathe can automatically move the cutting head at a certain rate so that it cuts a certain number of threads per inch. And there's this table of complex things you move, but there's one thing that's at the dial. And so he tried 3 different settings and it didn't get the right one. He's like, okay, well, obviously the whole thing is wrong. And he made the analogy that the lathe is actually a calculator. It's just like it's doing with gears. And it's just very specific. It's not like a Texas Instruments calculator where you punch in numbers and you get a result. It's you want to make threads of varying number of threads per inch. Well, here's this equation between metric or imperial, and you can make 12 threads per inch or 15 or 18 or whatever. And so he was kind of like trying to figure out like, why isn't it cutting it correctly? And so that made me think of, well, today, machine learning engineers, when they get a data set, they go, okay, my boss says I need a model to do X, Y, Z. So they get the data set. They use transfer learning. So they'll go to Google, they'll go to PyTorch, they'll download a base model like ResNet, MobileNet, DenseNet, or whatever, or YOLO. And then they'll throw on more layers and they'll train. But really, there's not that many knobs that you can tweak. Like, to a certain extent, it's kind of random.
Are there not that many knobs to tweak, or do the knobs exist, but we just can't see them or use them?
It's both. So an engineer might get the data set, they'll go download ResNet or YOLO, they'll add a couple more dense layers and they'll train it for 20, 30, 100, 1,000 epochs. They'll look at the results. And then they'll say, well, it was 80% correct or it was 20% correct, whatever it is. But they can't really do what Adam did, which is like, okay, let me put the setting to 18 threads per inch and let me run it. Now let me do 25 threads per inch and let me run it. And then to really systematically go through and figure it out. Like today, when a machine engineer sees their model plateaued at like 80%. Well, okay, so you get a new picture of a cat and you run it through and it gets it correct. You get 20 more pictures and half of them are wrong. Well, you don't really know why. You don't know how.
You use Adam's thing, you don't know even the number of gears.
You don't.
Yeah, on this lathe, on the machine learning lathe, much less which gear or gears to tweak, correct?
Yep. And in the case of Adam, he had that nice table of like 0, B, F, whatever. And so he has a nice table that tells him all the possible calculations that are possible with all these levers. We don't have that for machine learning model. It's not like when John, developer, goes to train a model, he knows that there's like this set of equations that matches perfectly to his data set. Like he fed it, and then there's infinite number of possible permutations, and he has no clue what it is.
Well, so that's pretty dire, from a problem solver's perspective. So what interest would a problem solver have in getting into machine learning, and or what can a problem solver do now or in the future?
Well, so today most people just think, well, okay, I can't. The current train of thought in the industry is you can't understand weights, so just get more data. But I think that's wrong. You still need more data, but you should try to figure out what the weights are doing. So we have to start building tools. We have to start building the theories and ideas about, like, how do we figure out what that table is? What's the equivalent of that lathe table? And once we know that, what's the equivalent of the gears inside the gearbox? So what are the gears in that model? Which weights contribute to that particular gear? If we can identify all those gears, well, now we have something we can actually quantify and test reliably. So that if we want to align a model, a large language model, and we know what the gears are, then it's a straightforward thing of like, hey, here's the gears, here's the input, here's the output. We just make the change.
So right now, everything in machine learning, well, not everything, but a lot, it's primarily more data, more layers, more money, more power, right?
Yes. Yep.
And that's the solution to everything. And what you're saying is that the future solutions have to be other gears, like fewer, right? Less data, fewer layers, less money.
Yep.
I mean, that is the future?
Well, so there is a small minority, as I would say probably 1 to 2% of the entire ML industry is looking into the idea of interpretability, of being able to identify circuits in these models. So it's still very young, it's still in the infant stages, but there are people, there's a few small groups around the world. There's a small group on the West Coast, small group on the East Coast, and a small group around London that are trying to do this kind of thing of like, can we identify what the circuits are, which is the same thing as a gear? What are the gears of this model? Can we identify it? And can we come up with a formula for how do we figure out what the gears are?
So you think in the future that will happen?
Well, I think it has to happen.
Okay. Necessity is the mother of all invention, right? So it's going to be a necessity.
Yeah, because there was a paper earlier this year about increasing the contacts to 1 billion by Microsoft because they're working with OpenAI. Well, they did small experiments to prove that a bitmap index could do potentially 1 billion, but like that's a crazy amount of hardware you need to do it.
Yeah. There's only like 5 companies on the planet that could even take that endeavor on.
Right. They could do the experiment and test it and spend a year to get it to work, but they couldn't scale it. It's not something you could actually deploy and have 100 million people use it.
So back with the Adam Savage analogy. So right now, AI is essentially a lathe with a gearbox that we can't see.
Yeah.
And we need to understand and discover the gearbox. So we need to see it,
right?
Do some comparisons so we can see like what that chart means, or someone needs to build that chart. Yeah. And then once we have that chart, then we can start tweaking the dials and getting different, cut lengths and depths and whatnot.
Yeah, because right now it's kind of like someone reaching into a bucket of bolts and then randomly trying to cut threads that are match the bolt.
No.
Like, all right, this is the 80th time. Is it gonna work? Nope.
It's just, it's actually amazing to me that people are like motivated to get into this industry because it really seems kind of mindless. It's a bunch. I know it takes a lot of skill to get into it, but the actual work that you're doing it's monkey work. I mean,
Well, it's hard.
throw more data at it, right? More, everything. And I think it'll be, I think that, put it this way, I think the ML engineers will really enjoy the future of being able to see the gears and mess with them.
Yeah, I think so.
Well, this is great. Great discussion. Peter, keep us in the loop as you see some of these things pop up. And that paper, for example, we should put that in the discussion box. So thanks, everybody. We will continue to try to entertain you with relevant topics of the day. Always comment, like, share, subscribe, all those things. And we'll keep the videos coming. Take care, everybody.